John, let's study expressions and equations in algebra.
When we solve problems in arithmetic, like 2 plus 2 is 4, or 10 minus 4 is 6, like 10 divided by 5 is 2, or 4 times 2 is 8. Specific values are stated and calculated, but in algebraic expressions we see something strange. Letters called variables have values that can change. Look at 2 plus x, what's the value of x? Don't get perplexed, the explanation isn't too complex. If x equals 6, then the value is 8. Or if we say x is 3, 5's what we'll calculate. The expression's value changes based on the variable's value, and in this case the sum will be any number plus 2.
Letters stand for numbers in algebra. They're called variables and they can change on ya. You can evaluate an expression's value, but it depends on the variable's value to make it true.
Now let's explore algebraic expressions in our lives, like shipping a cube-shaped box to my Valentine. S to the third power's a volume formula. S represents a side. It's the variable letting me know if my game will fit inside. If the value of S is 2 feet, the volume's a cubic feet. My gift will fit inside. I hope she thinks it's sweet. Now to wrap my present up, I'll find the surface area. I know A equals 6. S squared is the area formula. S is the variable, but since I already know the length's value is 2, I'll plug in the 2 feet and then I know just what to do. 2 squared is 4, then times 6 is 24. I'm using algebra to get my crush to like me even more.
Letters stand for numbers in algebra. They're called variables and they can change on ya. You can evaluate an expression's value, but it depends on the variable's value to make it true.
To identify parts of expressions, we use mathematical terms. Some product, factor, quotient, coefficient term are words we will learn. We find the products when we multiply, quotients when we divide. But let's look at the vocab closer and take a deep dive. For example, let's describe the expression 3 times 2 plus 4. We can describe it as the product of 2 factors. And if we look at just 2 plus 4, we can either see it has the sum of 2 terms or a single entity. The next word we'll review is the coefficient. Let's look at n plus n plus n plus n. We could say 4 times n or 4n without the sign. 4's called the coefficient, a number telling us how many times to multiply.
Letters stand for numbers in algebra. They're called variables and they can change on ya. You can evaluate an expression's value, but it depends. It depends. It depends on the variable's value to make it true.
John, you are very smart. With a bit of focus, attention to detail, and patience, you can excel in any subject. Now, John, let's review the key points from your school courses and exams together.
John, let's review everything together first, and then we'll come back and work on a few new problems for each type of question.
John, you are very smart. With a bit of focus, attention to detail, and patience, you can excel in any subject. Now, John, let's take a 5-minute break and then continue studying.
John, how can I say you're a blessing in every way? So smart, so diligent and strong. Doesn't the Lord bless you all along? I'll stay humble, kind and true, trust in God in all I do. With His grace I'll walk each day, His love will guide me all the way. John is the best brother. John is the best brother. John is the best brother. John, can you show Raymond the way? Teach him how to grow each day. Can you guide him with steady care? Teach patience, kindness, and love to share. I'll be a rock, I'll be his guide, standing strong right by his side. Through patience, wisdom, and love profound, I'll help him rise on steady ground. John is the best brother. John is the best brother. John is the best brother. John, what about Angelia, so sweet? Can you show her how to stand on her feet? Teach her wisdom, courage, and grace. Give her strength in life's embrace. I'll teach her peace and patience too. Remind her God will see her through. With steady love I'll light her way, so she can shine bright every day. John is the best brother. John is the best brother. John is the best brother. John, who gives us all this grace, who keeps us steady in life's race, who watches us with endless care and fills our hearts with love to spare. It's the Lord who blesses every hour, who fills us with His mighty power. Through Him we grow and live our best, for His love gives us peace and rest. John is the best brother. John is the best brother. John is the best brother. John, you're a blessing, strong and true. God's grace and love will follow you. Stay humble, steady, patient and kind. The Lord will bless your heart and mind. John is the best brother. John is the best brother.
John, you're doing exceptionally well. You understand and grasp new knowledge quickly. You're truly a genius. Alright, let's create some practice problems together to review your school courses and exams. John, what are terms, factors, and coefficients in algebraic expressions?
In algebraic expressions, terms are individual components separated by addition or subtraction. Factors are quantities multiplied together to form a term. Coefficients are numerical values multiplied by variables within a term. Constants are standalone numbers without variables. John, let's review what your teacher had explained what he terms factors and coefficients in algebraic expressions are. John, let's review what your teacher had explained what he terms factors and coefficients in algebraic expressions are.
What I want to do in this video is think about how expressions are formed and the words we use to describe the different parts of an expression. And the reason why this is useful is when you hear other people refer to some expression and say, oh, I don't agree with the second term, or the third term has 4 factors, or why is the coefficient on that term 6? You'll know what they're talking about and you can communicate in the same way. So let's think about what those words actually mean. So we have an expression here, and the first thing I want to think about are the terms of an expression, or what a term is. And one way to think about it is a term of an expression are the things, or the terms are the things that are getting added and subtracted. So for example, in this expression right over here, you have 3 things that are getting added and subtracted. The first thing, you're taking 2 times 3, you're adding that to 4, and then from that you're subtracting 7y. So in this example, you have 3 terms. The first term is 2 times 3. The second term is just the number 4, and the third term is the number, or is 7 times y. Now let's think about the term factor. And when people are talking about a factor, especially in terms of an expression, they're talking about the things that are getting multiplied in each term. So for example, if you said, what are the factors of the first term? The first term refers to this one right over here, 2 times 3, and there's 2 factors. There's a 2 and a 3, and they are being multiplied by each other. So here you have 2 factors in the first term. What about the second term? The second term right over here, this was the first term. The second term here has only 1 factor, just the 4. It's not being multiplied by anything. And the third term here, once again, has 2 factors. It's the product of 7 times y. So we have 2 factors here. We have a 7 and a y. And this constant factor here, this number 7 that is multiplying the variable, also has a special name. It is called the coefficient of this term. Coefficient. And the coefficient is the non-variable that multiplies the rest of the term. That's one way of thinking about it. So here's 7y, even if it was 7xy or 7xyz or 7xyz squared, that non-variable that's multiplying everything else we would consider to be the coefficient. Now let's do a few more examples. And in each of these, I encourage you actually right now to pause the video. Think about what the terms are. How many terms are there in each expression? How many factors in each term? And what are the coefficients? So let's look at this first one. It's clear that we have 3 things being added together. This is the first term, this is the second term, and this is the third term. So this is the first term, this is the second term, this is the third term. And they each have 2 factors. This first one has the factors 3 and x. The second one here has the factors x and y. And this third one has the factors y and z. Now, what are the coefficients here? Well, remember, coefficients was a non-variable multiplying a bunch of other variables. And so here, the coefficient in this first term right over here is a 3. Now you might be saying, well, what about the coefficients on these terms right over here? Depending on how you think about it, one way to say is, well, xy is the same thing as 1 times xy. So some people would say that, hey, you have a coefficient of 1 here on the xy, or it's implicitly there. It wasn't written, but you're multiplying everything by 1. And that might be subject to a little bit of interpretation one way or another. Now this one is really interesting. Because if we look at the bigger expression, if we look at the whole thing, it's clearly made up of 3 terms. The first term is xyz. The second term is x plus 1, that thing, whole thing, times y. And then the third term is 4x. And if you look at that level, if you look at the first term and you say, well, how many factors does that have? Well, you would say that it has 3 factors, x, y, and z. How many factors does the second term have? Well, you could say, well, it has 2 factors. One factor is x plus y, and then the other factor is y. It's multiplying the first factor is x plus 1, and the second one is y. It's multiplying this expression. This expression itself the smaller expression itself is one of the factors, and the other one is y. And then this third one also has two factors, a 4 and an x. And if someone said, hey, what's the coefficient on this term? You would say, hey, look, the coefficient is the 4. Now let's look at this one over here. Actually, before I look at that one, what was interesting about this is that here you had a little smaller expression itself acting as one of the factors. So then you can go and then zoom in on this expression right over here, and you can ask the same question. On this smaller expression, how many terms does it have? Well, it has two terms, an x and a 1. Those are the two things being added or subtracted, and each of them have exactly one factor. So when we're giving these, you can keep nesting these expressions to think about when you talk about terms or factors of terms, you have to really specify what part of the nesting you're thinking about. If you're talking about the terms of this whole expression, there's 1, 2, 3. But then if you go, you could look at this sub-expression, which itself is a factor of a term, and say, oh, well, there's only 2 terms in this one. Now let's look at this one. How many terms? Well, once again, there's clearly 3. Actually, let me add one more because I'm tired of expressions with 3 terms. So I'm just going to add a 1 here. So now we clearly have 4 terms. This is the first term, second term, third term, fourth term. And how many factors are in each of them? Well, this is interesting. You might say, well, the factors are the things that are being multiplied, but here I'm dividing by y. But remember, dividing by y is the same thing as multiplying by its reciprocal. So it would usually be considered to have 3 factors here, where the factors are 3, x, and 1 over y. If you multiply 3 times x times 1 over y, you're going to get exactly what you have right over here. So you would say this has 3 factors. If someone asks, what's the coefficient here? Well, you'd say, well, that 3 is the coefficient. Here, how many factors do you have? And this is a little bit tricky, because you might say, well, isn't 5x squared times y, isn't that equal to 5 times x times y? And you'd be right, and so it'd be very tempting to say that you have 4 factors, but the convention, the tradition that most people use, is that they consider the exponent with x as a base as just one factor, as just one factor. So traditionally, people will say this has 3 factors. It has a 5, x squared, and a y. X squared is just considered a factor, and once again, what's the coefficient? It's the 5. So with that in mind, how many factors here? Well, you have 3 factors here. You have an x, you have a y squared, and you have a z to the 5th. And then finally, this last term, it's a constant term. How many factors does it have? Well, it's just 1. It's just got a 1 sitting there. It's not being multiplied by anything.
How to write algebraic expressions from word problems. Example 1. The price of a visit to the dentist is $50. If the dentist fills any cavities, an additional charge of $100 per cavity gets added to the bill. If the dentist finds V cavities, what will the cost of the visit be? Write your answer as an expression.
Example 2. Sunny earns $12 per hour delivering cakes. She worked for X hours this week. Unfortunately, she was charged $15 for a late delivery on Tuesday. How much money did Sunny earn this week? Write your answer as an expression.
Example 3. There are C players on the Cougars hockey team. The team scored a total of 36 goals this season. One of the players, Matthew, scored more goals than the average per player. How many goals did Matthew score? Write your answer as an expression.
Please write the mathematical expression for the following word problem, a number greater than 6. The sum of 6 and a number plus 6.
The difference of 25 and x, a number less than 25, a number subtracted from 25.
The product of a number and 3, a number multiplied by 3 times a number.
A number divided by 12, the quotient of s, and 12, a number split into 12 groups.
Practice. Write an algebraic expression for each phrase.
12 more than m, x times 6, 25 less than a, s divided by 10, the sum of 6 and k, twice x, for more than twice p. Write each as an algebraic expression. 1310 less than 1414 half of 16.15, the quotient of a number, and 616 v squared. 17t more than 918 3 cubed. 19 the quotient of 24, and 820 the sum of 2, and 12.21 p cubed. 20 to the product of 5 and x. 23 to the fourth 20 for twice 11.
Evaluate each expression. 25 10 minus 6 26 to cubed. 27 twice 12 28 11 increased by 5. 29 6 times 10 30 for times 8.
Simplifying variable expressions. 1 minus 3p plus 6p to be 3 plus 6 to be 3 7xx for 7p 10p. 5 minus 10 volt plus 6 volts. 6 minus 9 revolution plus 10 R.
John,
7
you are
9
very
plus
smart.
5
With a bit of
revolutions, 9
focus,
revolutions,
attention to
8
detail,
1 3
and
volts
patience,
plus 10
you can excel in
0.95
any
n
subject.
plus 9
Now,
n.
John,
John, for B
let's
plus
take a
6 minus
5-minute
4
break and then continue studying.
Merry Christmas, John, and a Happy New Year. You're so bright, you work so hard, it's clear. A heart of gold, so pure and kind. God's blessings for you will always shine. John, you're a shining star. 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 John, you're a shining star.
Be a guide to Raymond, show him the way, teach him to grow strong each day. Be the best brother, patient and true, so he can reflect the best of you. John, lead with all your heart. John, lead with all your heart. John, lead with all your heart. John, lead with all your. John, lead with all your heart.
For sweet Angelia, be her light. Teach her courage, show her what's right. Be steady, kind, and wise each day. Help her rise in her unique way.
John, guide with love and care. John, guide with love and care. John, guide with love and care.
John, guide with love and care. John, guide with love and care.
All of this comes from God above. He fills us with His endless love.
Thank Him for the gifts we share and trust His grace is always there. John, trust in God's great plan. 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 John, trust in God's great plan.
Merry Christmas.